In the world of global travel, airports worldwide have a few things in common. Busy terminals filled with passengers and busy runways welcoming a constant stream of incoming aircraft. A plethora of safety concerns exist when it comes to air travel, and rubber buildup on the runway left by rapid acceleration of landing aircraft wheels are among the most important. This rubber buildup leads to decreased friction, and when left uncleaned over time, will prevent very slippery surface, particularly in wet conditions. Although a variety of methods are employed to remove these rubber deposits, none of them are more effective than the method of high-pressure water blasting. There are two very distinct methods in which the water blasting process is executed on the runway surface. The traditional method of movement is a lateral method of removal. With this method, a 10-inch wide cleaning head moves on a lateral mounted track across the front of the supporting vehicle as the vehicle moves slowly down the length of the runway. The backward movement of the blasting head attempts to directly correlate to the forward movement of the vehicle. However, here at Water Blasting Technologies, we have popularized a much different pattern of removal known as the linear method. With this method, the cleaning head or cleaning heads moved in a fixed position down the entire length of the runway in the exact same direction as aircraft land. Now let's take a closer look at the lateral method of removal. Remember, in this method, we have a 10-inch blasting head moving in a lateral pattern back and forth across the front of the vehicle as the vehicle moves linearly down the runway. This pattern leaves an overlap in between each of the corresponding tracks. According to our research, this overlap usually is 2 to 4 inches in width. If you do the math, an average rubberized area being about 2,000 feet in length, and the average overlap being about 2 inches in width. So if you take a 10-inch blasting head, reduce it by 2 inches, that means an effective blasting pattern of 8 inches. You take the 2,000 foot long rubberized area, multiply it times 12 to get inches, and then divide it by 8. This means that for each linear pass of a lateral tracked machine, there are 3,000 of these lateral overlaps per linear pass. So consider this. As this 10-inch head moves to the left and then to the right, assuming a 2-inch overlap, that would be 0.16 square feet consumed in an overlap as the unit travels from left to right. If the blasting width is 6.5 feet in the track, that would mean for every movement across, there's 1.08 square feet wasted due to this overlap. The lateral overlaps on an average end of a rubberized runway would result in a net wasted overlap area of 25,000 square feet. As you'll notice, the lateral tracking vehicles leave a scalloped edge down the side, and when it comes back to do the next pass, the points of these scallops are opposing one another. This results in a net overlap per linear pass of 1,333 square feet. Now let's take a closer look at the linear method of removal popularized by Water Blasting Technologies. A few clever innovations have made this method far more efficient than the competitive method of lateral movement. First off, let's take a look at the blasting heads. In this setup, you'll notice 2 blasting heads instead of 1, and a width of anywhere from 28 to 40 inches of removal width. In this particular case, we have 2 21-inch blasting heads married together for a total of 42-inch blasting width. However, a 2-inch overlap is required. Notice the overlap is far less than the 8 to 12 inches required by a lateral machine. How is this possible? First of all, the vehicle is traveling very quickly when compared to a lateral movement machine. Secondly, there are no scalloped edges left by the machine as it travels in a straight pattern. You need to understand something about the blasting pattern and the circles in which the spray bars are moving in. There's jets all along the continuum of the spray bar, but the jets at the outer edge of the spray bar are traveling at a much faster speed than the nozzles on the inside of the spray bar. And what we do to mitigate the overlap is we put a diameter in the outer nozzles, half the diameter of what they need to effectively clean the surface, so that when the nozzles overlap in the middle, they're effectively cleaned only once, not twice. Therefore, as the machine travels, you'll see on the animation that the outer edges are only half cleaned, not fully cleaned. When we overlap the second time, that area is fully cleaned, and the area of actual overlap is very, very minimal. If we take a 2-inch overlap, divide it by 12 to come up with feet so that we can calculate square feet, you'll see that 0.17 multiplied times the 2,000 feet distance results in 333 square feet wasted due to overlap per pass. We then take that 333 square feet, multiply it times the 15 passes necessary, and you quickly calculate that there is 5,000 square feet wasted in overlaps on an area of runway to be cleaned. Compare that 5,000 square feet with the 35,306 square feet represented by the laterally movement machine. Now, there are two things to consider when talking about these overlaps. One of them is efficiency. Another of them is impact to the surface. True enough that water jets can clean a surface and do so and create very little to no impact to the surface. However, if you leave that machine sit in any area for any length of time, it will most certainly damage the runway. Just as important is the efficiency of the machine. How fast does the machine clean the surface? If you're passing over areas 2 and 3 times, it doesn't make any sense. Lateral track machines advertise 800 square meters per hour. We have proven the world over our ability to remove 1,800 square meters per hour. Take a look here at how impossible it is to see what you've blasted on the laterally tracking machines. And then conversely, take a look at how easy it is to see the surface immediately in front of and immediately behind our linear way of thinking. Wherever there's runway rubber to remove, very often there's some paint to remove with it. What about the ability to adjust blasting width for painted lines? What about double yellow lines? We can remove a double yellow line while leaving the space in between untouched. And how about this? A stripe hog is smooth. Goes down the runway with no shaking whatsoever. In fact, if you operate a lateral tracking machine for any length of time, it's been said that you may turn into one of these. Thank you for your time. And if in the end you have more questions, don't hesitate to call me or one of my competent sales staff. Thank you.